Now let's do an example. The sample space S is the whole numbers starting at 1 and less than 20. So S being the sample space will equal, so here's the sample space, 1 through 19. It says let event A equal the even numbers. So let's go ahead and put that in. Event A is the even numbers, so here's our even numbers. And event B are numbers greater than 13. Note that that does not include 13. It says greater than 13. Now let's find the probability of A. So that's the probability that you would get an even number. To do this, we're going to count up the number of items in A, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9, and we put that over, so divided by the total number of numbers. So the total number of possible outcomes is always on the bottom, which in our case is a total number in the sample space, which is 19. So 9 over 19 is the probability of A. The probability of B, we're going to do the same thing. 1, 2, 3, 4, 5, 6. So there's 6 numbers that are greater than 13 out of a total possible of 19. For the next one, it says A and B. So we want to list all of the values that are in A and also in B. So let's take a look. This starts at 14. So we have 14 in both of them. We have 16 and 18 in both of them. Frequently when I do this, I cross them out as I go along just to keep track of everything, but I won't do that here because I don't want to make a mess. So now let's do what is in A or B. So remember A or B is A and B, and B. So it's going to be 2, 4, 6, 8, 10, 12. Now 14's in there twice, but we don't put 14 twice. We only write it once. 14. Then we have 15, 16, 17, 18, 19. Now that we have this information, let's go ahead and find what is the probability of A and B. Now we've made it very easy for ourselves because all we have to do, the probability that A and B would occur, there's 1, 2, 3. 3 out of our total in the sample space is 19. We're going to do the same thing for the probability of A or B. We're going to go ahead and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 out of a total of 19. F says A prime equals, remember A prime is the complement and it's what's not in A. So what's not in A is everything left over in the sample space. So in this case, it's the odd numbers. Then it wants to know what's the probability of A prime. Well, the probability, let's count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 possible in A prime divided by the total number, which is 19. Now it's asking us in G to do the probability of A plus the probability of A prime. Well, we already have the probability of A up here, which is 9 out of 19, plus A prime, 10 out of 19. And if you recall, when you're adding these two together, they should, and they do, equal 1. Right, so it equals 19 out of 19, which equals 1. Now let's take a look at the last part of this example. It's the probability of A given B. So if you recall, the probability of A given B can be rewritten as the probability A and B over probability of B. So we are just going to find this. And luckily, we have all this information we've already calculated above us. So the probability of A and B is 3 over 19. And we put that over the probability of B, which is 6 over 19. We'll get our calculator, parentheses 3 divided by 19, close our parentheses, divided by parentheses 6 divided by 19, close parentheses, equals 0.5. Next, we are going to do what is the probability of B given A. So it's the same thing. We do the probability A and B over, this time it's the probability of A. Okay, so for this one, we already have the probability of A and B, it's 3 over 19, divided by the probability of A, which is 9 over 19. So again, let's put that in our calculator. And so now we are going to do 3 divided by 19, close our parentheses, divided by parentheses, 9 divided by 19, close parentheses. 0.33333, which I know is 3, whereas a fraction is 1/3, but we can leave it as a decimal. And then it asks us, are the probabilities equal? The answer is a big resounding no.